On this page, we'll see what can go wrong as far as errors go. On the previous page and the one before that, we talked a little bit about what can go wrong as far as our conclusions we draw from the math. But this would be what kind of error you can actually make when you're doing a study as far as the math goes. Statistical investigations involve making decisions in the face of uncertainty. So there's always some chance of making a wrong decision. In hypothesis testing, two types of wrong decisions can occur. First, if the null hypothesis is true, but we reject it, the error is called a type 1 error. If the null hypothesis is false, but we fail to reject it, this is called a type 2 error. The following table summarizes type 1 and type 2 errors. So either the null hypothesis is true, but we reject it on accident. We shouldn't have rejected it. That's a type 1 error. If the null hypothesis is true, but we fail to reject it, there's not enough information to reject it, then that's the right decision. If the null hypothesis is false and we reject it, that's a good thing because it was false anyway. But if it's false and we fail to reject it, that's a type 2 error. So type 1 error is kind of like the person that's on trial is innocent, but the results of the trial say that they're actually guilty. On the other hand, the type 2 error is like the person's guilty, but we said that they were not guilty. Sort of. Type 1 and type 2 errors are not caused by mistakes. These errors are the results of random chance sometimes. The data provides evidence for a conclusion that is false. It's no one's fault, but it's still the math that might go wrong just as far as random chance goes. Let's look at an example here. Data use on smartphones. Okay. In the previous example, we looked at hypothesis testing about data usage on smartphones. The researchers investigated the claim that the mean data usage for all teens is greater than 62 megabytes. The sample mean was 75 megabytes. The p-value was approximately 0.023. In this situation, the p-value is the probability that we will get a sample mean of 75 megabytes or higher if the true mean is 62 megabytes. Notice that the result, 75 megabytes, isn't impossible, only very unusual. The result is rare enough that we question whether the null hypothesis is true. This is why we reject the null hypothesis. But it is possible that the null hypothesis is true and the researchers happen to get a very unusual sample mean. In this case, the result is just due to chance, and the data have led to a type 1 error. We wouldn't want to reject the null hypothesis when it's actually true. So for example, back to the white male support for Obama in 2012 example that we saw in previous pages, in that case, we conducted a hypothesis test using poll results to determine if white male support for Obama in 2012 would be less than 40%. Our poll of white males showed 35% planning to vote for Obama in 2012. Based on the sampling distribution, we estimated the p-value as 0.078. In this situation, the p-value is the probability that we will get a sample proportion of 0.35 or less if 0.40 of the population of white males supports Obama. At the 5% level, the poll did not give strong evidence for us to conclude that less than 40% of white males will vote for Obama in 2012. Which type of error is possible in this situation? If in fact it is true that less than 40% of this population support Obama, then the data led to a type 2 error, failing to reject a null hypothesis that is false. In other words, we failed to accept an alternative hypothesis that is true. We definitely did not make a type 1 error here because type 1 errors require that we reject the null hypothesis, and that was not what we did in that case.